Hi again, this is John Lundquist, Palette Academy, and this is Lesson 5-1, Algebra 2, Trig Ratios. And trig ratios have to do with a right triangle, and that's what the Greeks came up with. And what they did is they said, if you're given an angle and a side of a right triangle, I can figure out the other two sides and using trig ratios. And they came up with 6, but we're going to only use 3. The sine, the cosine, the tangent. And they're defined. They define these as a ratio of in respect to a reference angle. So you have to pick an angle. And in respect to this reference angle, we have 3 sides. We have the opposite side, which is across the triangle opposite. Excuse me. And then we have the adjacent side. Adjacent means next to. And I wonder if it means touching too. I'm not sure. Anyway, this guy is touching this angle, and this is adjacent side too. But this is a special one. This is hypotenuse. And I looked up the word hypotenuse in Greek, and it could mean support or ladder, or it's like a supporting wall that you support against or drop a ladder against a wall. Anyway, but they're unsure. I don't know why they're unsure about that. Anyway, but they call it hypotenuse. And that's the thing that's opposite the right angle. Here's the right angle. This is 90 degrees. So, and this is how we define them. The sine of A, in respect to this reference angle, is defined as the opposite side over the length of the opposite side over the hypotenuse. The cosine, which it really means the complement of the sine, which means that the sine and the cosine are equal if you use the cosine of B. Well, never mind. It'll come clear as we work. So anyway, and then we have tangent, which is just defined as the opposite over the adjacent. And you got to memorize these. Should be put to memory. And some people use the acrostic or the acronym SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, SOHCAHTOA. Okay, so what we do then is we can find, and we'll use this reference triangle. And this is the reference angle right here. This guy right here, D. And so this is the opposite side. And this is the hypotenuse. And this is the adjacent. And then we can say, well, the sine of D, in respect to D, the sine is the opposite over the hypotenuse, which is 3 over 5. And the cosine is the adjacent over the hypotenuse, which is 4 over 5. And the tangent is opposite over the adjacent, which is 3 over 4. And then we can just figure out the decimal numbers by bringing in a calculator, turning it on. And notice I already did it. Let's clear this. Let's clear it off. And then 3 divided by 5 is 0.6, so it's 0.6. And then, oops, 4 divided by 5 is 0.8, 0.8. And I don't have to know, I know what 3 divided by 4 is. It's 0.75. 0.75. Okay. Now, that's it. I mean, that's how you figure out the ratios. So let's just take a look at saying, well, what about the sine of E? So that changes things. It doesn't change the hypotenuse, but it changes the the opposite and adjacent, because now we're going to use E as a reference. So now this is the opposite, this is the adjacent. So E, the sine of E in respect to E is 4 over 5. So notice that 4 over 5 is the same as the cosine of D. That's why they say the complement of the complement of D is the sine of E. That's the deal. Although nobody ever uses it, don't worry about it. That's 0.8. And then cosine of E is 3 over 5, which is the same as the sine of D. Notice it's complement. So 0.6. And then the tangent is 4 over, so this changes. It's 4 over 3. 1.3 repeating by bringing this 4 divided by 3. Notice it's 1.33333. I know 1/3 is always 3 repeating. And then you can just put a little line over the 3, which means it's repeating. Opposite over the adjacent. So the last thing you have to do in this exercise, so this is most of the exercise, is figuring out the ratios in respect to a triangle. Oh, by the way, this is a legit triangle. If I was to, I know it's a right triangle because of Pythagorean theorem, which is a squared plus b squared equals c squared. A squared plus b squared equals c squared. And this is, whoops, this is 3 squared plus 4 squared equals 5 squared. And this we call this turns out to be 9 plus 16 equals 25. And sure enough, 9 plus 16 is 25 equals 25. And the Greeks love this stuff. They called it a Pythagorean triplet. Boy, this doesn't write triplet. Anyway, so there's all kinds of tricks. There's not very many, but there's a few, and the Greeks love those when they have 3 whole numbers that make a right triangle. Okay, so the last thing we got to do is do this, sine of 25. Okay, so this is really simple, really simple. You bring in your calculator. First thing you do is clear this out, and that's probably a good idea. And you go to mode. And see this here, right here, radian degree. Well, you better have it better be degree, because if it's radians, you're going to get a different number, because we're using degrees for now. And we want to hit enter, because that's what we want. We want that degree, and then we can go clear that out. I think we can clear that out, yep. And then I'm going to go sine of 25. And I don't really have to close it, but then I get this big number here. And then usually we do it to the first 4 to the 10,000s. This is a tenths place, hundredths place, thousands, 10,000s. 0.226. Okay. So this is 0.22. What was it again? 0.4226. So that's not right. I'll erase that. And then I'm going to put 0.4226. And then cosine of 75, I do cosine of 75. I don't even have to put close parentheses. 0.2588. Okay, so 0.2588. Little equal sign there, and then tangent This is sine, cosine, tangent, these three guys. Tangent of 54 degrees. 1.3764 rounded. 1.3764 rounded. 1.3764. And that's it. That'll be that's the first exercise. Have any questions? Just come and see me. Good day.